Here's my Caapi. It's doing pretty well. It looks like it's dead, but it's not. It's just the leaves falling off due to the cold weather. But you can see there's new growth. Lots of growing points all over the stems. An easy way to tell if it's alive, just give it a light scratch. If it's green, it's alive. There's some dead stems here. This one's still green, but the point is dead. So I'm gonna give this a trim to remove or cut back the dead stems, like here. And I'm also going to harvest the roots here in this semi-hydroponic setup. There's a top portion that has soil. It's pretty compact. And then there's an air portion, and then the water reserve. I've only been using pure water and whatever nutrients goes down from top watering. And I've not had issues. The last time I checked, the roots were all healthy. There's only a little bit of algae here, but overall it's a fairly clean setup for Caapi. It's still fairly small, about pinky thickness, but the roots are strong and healthy, and I'm going to harvest the roots here. So based on older scientific papers, the roots are actually fairly strong, yielding around 2% alkaloids for harmalas, and in some cases that's stronger than the stem and the leaves. Obviously that this isn't the easiest part of the plant to harvest. You would do much easier harvesting lots and lots of the vine, since these get massive. But my experiment that I'm setting up for either kratky or actual hydroponics, I'm going to try to do it to harvest the roots specifically, since in deep water cultures or kratky, the roots grow very large very quickly. I want to see if it's a viable option for obtaining harmalas. Syrian rue is a great and cheap alternative to just buy the seeds if you have access to it, but for me it's not readily available, and it's much more expensive. So I'll harvest, cutting back a portion of the top. I'll keep doing this grow setup, and then I'll trim the roots as well. So this time the water reserve is causing some issues based on the color. I mean, it's still alive since it's not pulling too easily, but you can see there's a lot of brown and some rotted roots as well. Since it'll be a chemical extraction, I'll just test this material as well, and I'll see if this water is contains harmalas as well under the black light. Here are the roots. You can see last time where I trimmed it back, and I'll be trimming just a little bit further down, but you can see the roots started to form a small amount of bark, and this is the air portion that remains in between the water layer. So I cut back maybe a third. This is just the the dead bark or the dead wood. I'll probably trim back a little bit more, since last time I did this I had a stronger growth rate. They seem to stall, and then after a prune back it does pretty good. So I tested squeezing this water, and there's a very faint fluorescence on their UV light, but it was so small that I just discarded it. It's not a big deal. So I trimmed back a bit more, and I added a half strength nutrient mix, and again I'll place it on top. There's going to be an air gap for a while. There won't be any water reaching the roots, but they'll grow into the water sooner or later. And yeah, this time I'll be covering the water reserve so there's less algae growth, and that's pretty much it. So I ended up with around 70 grams wet roots. I'm not going to dry them, since this is just to see if I can even yield something. The color is very blue, so I'd say it's low in harmaline and only or mainly contains harmine. So I'll do a quick boil on this, do 2 or 3 pulls, and then see if I can get a measurable yield. Here are the roots. I'll be drying this to have a rough estimate on the dry yield of the roots. Obviously some weight was lost due to the extraction. I did 3 slightly acidic water pulls in hot water, and then I reduced it down. I filtered once, reduced it down to 200 milliliters, and now hopefully here's a lye solution. Hopefully it'll precipitate. Maybe it's too dilute. And also I need to check the pH. So there's a slight color change already. It got lighter. And so the pH is fairly acidic, so I'll need quite a bit. I probably should have reduced the volume a bit more. Just check the pH again. Still acidic. I'll just so I'll be adding even more. So you can see that it's no longer transparent. Need to check the pH in a little bit to see if it's high enough. So the pH is high enough, and I'll stir it a little bit and then let it settle and try to get to see if I have a measurable yield or not. So after maybe 2 hours, you can see a precipitate formed. This is a very brown precipitate, and from my experience and opinion, this is either harmol or harmolol. It seems that the taproot or the roots does not contain harmine or harmaline like I said originally, but it contains, again, the harmol or harmolol. I'll do one more acid base on this. I'll filter and then vinegar and then precipitate again just to see. And since I do believe this is harmol or harmolol, whatever it is, I can actually precipitate this as a red citrate salt rather than doing vinegar. If I add a very high concentration of citric acid water, it'll precipitate out as a red salt. So I'll be doing that just to have an easier time to weighing this. So the brown precipitate that formed, I got this soft filtrate, and from here I'll do a mini acid base to see if I can get a normal precipitate. After letting it sit for a night, overnight, it had a little bit more. I'll see if I can recover that small amount. Just filter it. So I diluted the citric acid water. This has 6 grams of citric acid in it, which is a far excess, but it's still cloudy, and I want to filter it at least once before it decides to crystallize. So this is the impurities. I could probably even do an acid wash on this and it may dissolve some more, but under the UV light it's not really reactive. And here's the filtered solution. It's still a little cloudy, but it's also wanting to crystallize, so I'll decant this into the beaker again and leave it for a few hours, and it should form the red precipitate that I mentioned. Here's the filtered harmolite. You can see a blue, it's hard to see with the sun, but the blue there you go, the blue harmala glow. And I'll leave this for a few hours to see if it precipitates or not. So nothing precipitated after leaving it a while in the citric water solution. So what I did is very slowly increase the pH to just around 6-7-ish, but you want to stop before it starts forming the precipitates. If you stop just under 7, it forms this cloudy solution, and you can remove a color impurity, and it is possible that it's a type of harmala, but I've noticed I've had greater success with less acid-based washes if I carefully increase the pH and then filter. So I did a UV light, and the color is very bright and it's cleaner. And here is the same solution, but this is with the higher pH. You can see it stays a milky cloudy, and the harmalas here, they float rather than sink. Not that that matters much, but I'm guessing it's since it's very saturated sodium hydroxide solution. This was to prevent adding excess water, and it's not a huge deal. So after filtering, I'll start precipitating again, increasing with the light water. And you can see the difference and the clarity. And here's the second acid base. This is alkaline, and you can see a much lighter precipitate, but it's still fairly amorphous. I think that's how you pronounce it. It doesn't really have a shape, and I'm fairly certain it's I was saying Harmol, but I think it's Harman. But so in any case, I'll be filtering once more through a vacuum filter, collect this goo, and then this time, since it's already cleaner, I'll leave it in the citric water overnight, so to see if it'll precipitate or not. So I'm having some trouble trying to crystallize and purify this precipitate. I tried the Mansaki, which is basically just a salt brine in acidic solution. It precipitates the hydrochloric salts, but I am not having success with that. But in any case, it's yielding around 500 milligrams. It's still a little bit wet, so let's drop it to 300 milligrams. But I'm going to try using ethanol to see if I can get some form of crystals. So considering this is my first attempt, I first added near absolute ethanol, and not all of the brown precipitate dissolved. I should have filtered it, but I just skipped ahead since it was not acidic. I thought it may have influenced it. But after adding a small amount of hydrochloric acid, aqueous hydrochloric acid, it did not dissolve. So see how to film this. But after before I added the hydrochloric acid, it was not fluorescent, and after, it shows this very nice blue. It doesn't pick up too great on the camera, but it's a fairly deep blue fluorescence. It's not the glass. I can also see it flashing directly on top. And based on a very small amount of white precipitate that's forming, it is entirely possible it is salt, but I think this may be Harman, since the other harmalas in hydrochloric acid, hydrochloric salt, are soluble in ethanol, where this one, it's forming very thin white powder. So I'll evaporate this and we'll see. And next time I'll first filter out the dark insoluble material. It may still be fats or something, plant material, but you can see there's this precipitate that forms, and maybe following recrystallization it'll form some crystals or something. So I filtered the insoluble brown material as well as the white that precipitated, and that removed around 80 milligrams. So remaining is around 450 milligrams of the suspected Harman alkaloid. The original lye solution is forming another precipitate. It's just some minor amounts that remain, since sometimes it passes through the filter paper. I'll just leave this alone. I'll decant or siphon off the top layer, the alkaline layer, and then I'll try to see if it's enough to warrant a recovery. But here it's a very nice blue under the UV light, and I'll evaporate this and see what remains. Hopefully a crystal. This is the hydrochloric salt of the Caapi root extract. It does not precipitate like normal harmaline and harmine. I believe this is harmane. And from here I'll scrape this, try to weigh it. You can see some needles that try to form, and I'll go on from here. So I attempted one more recrystallization, but this time I used isopropanol, and you can see a precipitate formed. I'll leave this separate. It kind of looks like needles, but they're tiny. And then here is the alcohol, and you can see the blue fluorescence under the 365 UV light. So you can see a very dark blue, and I'll evaporate this separately from the precipitate. So overall, the roots are giving me a hard time, but later I'll give a rough estimate on the amount of harmalas, whichever one it is, and I'll see if it's worthwhile, my original idea of doing a hydroponic setup for the roots. And here's the weight of the dried roots. I'll make it around 10 grams, since I already boiled and filtered off some material. So it's approximately 10 grams, and I yielded approximately 300 milligrams of a more refined precipitate. I'm not entirely sure which is which, but this wasn't soluble. This could be just salt. And the fluorescence is with this alcohol layer. So taking off some losses here, let's say it's around 200 milligrams, and that would be a yield of around 200 or 2% yield. So originally I was planning on doing a deep water culture of the Caapi, but since I was unable to get a solid precipitate, I only got this hygroscopic goo. I'll just do a simple kratky, just a semi-hydroponic setup, and collect the roots and try to experiment that way. I won't be using an air pump since the yield isn't what I was expecting. In the end, the yield is around the 2% mark, and I will test this when next time I have a free I have a free day off or free weekend off, and I'll see if this is enough to activate the other alkaloid. This is around 200 milligrams, so it should be enough. And the way I'll test it is, like I mentioned, I'll take this and then see if it activates the other alkaloid.